So, very good morning, and today we will be talking about how we are bringing the agility and agile engineering blueprint by leveraging ODA. Okay. So, I will be talking about a bit of ODA canvas and the whole open digital architecture, how it has evolved, how large organizations are adopting it, how this is getting productionized, and how the future roadmap of ODA is looking forward, how the ODA canvas is evolving. And my colleague Naresh will be showing how it was done at Geo and what are the kind of tooling, what are the DevOps pipelines which were set up and all that. So, I think let us begin. Okay. So, just to set a context, we are at Geo, and you all know that Geo is a very large telco, and for last a few years, for about 8 to 9 years, the scalability of Geo has really gone from 0 to where it is now, which is about 500 million mobile customers and landline customers, and that is pretty huge. No, by no means it is small. And not only in terms of number of customers, but if we talk about the terms of mobile data consumption, then it is about going 50 exabyte per quarter, that kind of thing, which is even more than China Mobile, that kind of a data consumption. And China Mobile, by the way, is about 1 billion customers, and during ICC Champions Trophy final, where about 100 crore people were hooked in, the data consumption on the single day was, on the final day, was 500 petabytes or something. So, these are the kinds of scales which have been there, and so scale is fine, but the environment is not static, because every day some new requirement comes, and then that requirement impacts a number of platforms, a number of systems, and that requirement has to be delivered at a pace and with a fixed timeline. So, there is an event, there is something which is happening, there is a deadline, everybody has to join hands and deliver. So, the biggest challenges in front of us are definitely the scale, but these are the key principles on which we have been hopping on from day one. One is obviously agility, and then scalability and fungibility. So, these are the very key requirements for us from the very beginning, because I still remember when in 2010 there was initial, like Geo bought the license, and that time we were told that you have to go 1 million a day acquisition, and then that time kind of million in a month for all operators was okay, 1 million a day, so that kind of. So, agility was kind of always, and scale. So, million a day you have to deliver today, and then it has to increase, and then scale. So, initially when the things were launched, I think in 2016 or so, we were told 100 million 100 days, that kind of thing. So, the platforms had to scale, and we had to really burn our night oils, and many nights we were awake and all that. And the last principle was fungibility, right. So, it is from day one, the idea was that whatever is working, if you want to replace with a better software component, with a better platform, just take it out, put another one, it should work. So, that is the kind of principles we have been working. And today if I talk, so this has been working pretty successfully for years now, but today if I talk, the challenges are there were so many parallel teams which were working on it. Obviously, there are certain in-house platforms, there are certain COTS platforms, and also it's a pretty heterogeneous environment where technologies are different, where the way the architecture is done is different, and then there is a huge interdependence. So, even a small feature, as I said, will require maybe many platforms to change. And the operations team is always fearful. We don't want to put any release, right? Why? Because it's a running business. 500 million customers are on. So the moment I put a change, we don't know what will break, right? So it's a huge impact and risk for each release. So this is the ground reality in front of us. And what we thought, actually we architected our platforms from the very beginning on the right architectural principles, and we had collaborated with an organization, SD organization called TM Forum. Earlier it used to be called Telemanagement Forum, but TM Forum is like a globally well-known name now, and they worked on a architecture called open digital architecture, right? So we worked with them, and I'll be talking about how it has evolved, but there are basically 4 quadrants in this architecture, open digital architecture. So one is the business, when we talk about business capabilities, business processes, and then next is the information systems. So in business processes, it was very fondly called ETOM. So it's like E-Telecom Operations Map that time, but now ETOM everybody knows, may not be knowing the full forms, but ETOM is a pretty known term. And then the capability framework, and then information framework is again a well-known terminology was SID, SID, which is Share Information and Data Architecture, but then today it's just known as SID. So that's how it has evolved, wherein you start thinking on architecting how the information has to be modeled. So these are the basic thought process of conceptualizing, visualizing and designing your system which you want to, design the functionality which you want to do. And then came more concrete things, how the systems were designed, open APIs, components, CTKs, and the actual data models, actual schemas in the APIs, those were designed and standardized. And finally, the deployment and runtime environment, which is nothing but the canvas. That's where the real agility is coming up in the whole cycle. Next slide is a bit double click on this. So I've already covered that the business capability repository, TOM is the business side, and this piece is represented by a pretty detailed work, which is like the L0 processes, L1 processes, L2 processes, L3 processes, and pretty detailed work in 7 domains of information, and then the capabilities and processes are arranged, and then similarly the information systems, the implementations of open API data models, and finally everything to components which are deployable on a runtime environment called Canvas, and then we have operations framework and reference implementation. So the end-to-end governance involves all of them. Again, there are a lot of documentation and all is available, and what Geo has done is join hand with these kind of organizations, and what we have also done is formed an innovation hub. Innovation hub is run by TM Forum. Geo is sponsoring that, and we have all the big operators of the world and the big vendors of the world as members of them. That kind of innovation collaboration is happening. And just to bring that the ODA, how it has evolved over 25 years, as I said that initially the evolutionary path was just to work on common language and framework. So because whatever idea, so I'll tell you how the Geo was, when it was starting the operation, and I was, the main architect at that time from grounds up. And then, I had a big problem. Geo organization was growing, And a lot of people were pouring in from the industry. You know, somebody has done work in Airtel, somebody has done in different organization, the Hutch and so on, and IBMs of the world and whatnot. And then people were having experience of, you know, calling different things differently. So somebody would call it's a top up, somebody called it's a recharge, somebody's called product, somebody's called product offering, somebody's calling it something else. So I said, guys, we won't be able to deliver anything till we just formalize our terminology. So first problem was that, you know, defining a spade as a spade. You know, nobody is going to call this anything else in our email communication, in our documents, in anywhere. And that's where, you know, the main challenge at the initial stage was, and that's where TM Forum, ETOM, SID, and TAM, this was another framework, which was telecom application map. So how the applications have to be created, clubbed, you know, so all of them. So somebody might say, I have a subscription engine, somebody might say I have a charging engine, and you know, you might find some similarity in these, right? So a boundary of all of these applications, the capabilities, the processes, and the information models and the semantics around that was done. And that has evolved for 20 years now, and then came the open APIs. So we said all of this is fine, now how do we interact and how do we standardize them? And open APIs were done, and very recently the component work has been done. Open API and all is fine, but still how do we have a piece of software which is delivered, and then finally how it has to run on canvas. So this is the story how it has come up, and this has come up really beautifully. But coming to specifically component in canvas, which will be talking in today's talk, in today's session, is something how it has evolved. So there are, you know, two parts. One is ODA component and how it has to run. So as we see the ODA components, there is a completely directory of the components which have been identified as standard components, right? So you might decide as an organization that my a particular platform consists of maybe these 2 components or 3 components, or you might say my platform is half a component and all. That's another matter. But then when we talk to each other globally, we talk in terms of a standard group of functionality called component, and those are arranged in this manner. So it's not legible, but you can later on download all of these. So typically how they are arranged, one is party management, that means all customer, the partners, and also the entity, the owner, the person or the organization. So all related to all of that stuff. And then second piece is the core commerce management, where the business is done, where the transactions are done, ordering is done, and all that. And then there's a production management, which is like near to the network, how a particular functionality has to run on the telecom network, and then there is intelligence management and engagement. So all of this, so that means these components are basically Lego blocks. So that's how they are defined, and they have to deliver the agility, flexibility, and scalability, which I was talking about. That was a key principle for Geo anyway. And then this ODA canvas, which is like a system service layer, and then we'll be showing you a live demo today where all of these components sit. And the benefit of running this, that all the common functionality are then defined as operators. So this is Kubernetes based, containerized, and these canvas operators are Kubernetes operators. So if we see the component management API, observability, event management, identity, secrets, and so on, this list is increasing. And then in the latest ones, we are talking about carbon management, AI management, and all of that piece. So everything gets, you know, plugged into this, and the developers of specific components needs to focus only on the functionality, the capability. That's it. So all the standard things are available as components, as operators. Typically, this is how a component is specified. So if you see now, you will find the linkage of all of this. If suppose this is my component, it has got a number of processes, which are the ETOM processes. It has got number of data entities or the information model entities, which is equivalent of SID. So processes are equivalent of ETOM. And then there are certain exposed API, and there are certain dependent APIs which this component uses, and there is a set of functionality which it does. So ETOM, TAM, SID, Open API exposed, Open API dependent, finally all of them packaged in a component which can be deployed on canvas. So it's a pretty standardized form of developing a software, deploying it, running it, and with all the observability and SRE and whatnot, and then auto-scalable manner embedded with AI. Now this is a shape. How does it look like as a component? So then these are the APIs. Everything is accessible on APIs, and there are these 5 items in it: the core function, notification, security, environment dependency as management operation. That's how it looks like, a typical component definition. And this is just an example that in this diagram, all the green ones are the components. They have certain exposed APIs, and these exposed APIs interact with each other, and that's how the network of component runs. So if I need agility in any feature, I just say, and as an independent life cycle of a component, which is a backward compatible delivery of an enhanced version of a particular component, and then this all keeps on working. So I just need to bother about enhancing a particular component and deploying it, planning the deployment of one component. Now what Geo has done is, before this, what we decided that at least, to bring thousands of people on the same page, we decided to run a campaign of certifications. So we said that all our processes, all our information models, all our open APIs, all our data models have to be certified against what is mentioned by the standards organization, and that certification drive is running for almost like last 1 year. And on the certification leadership board, we are #1 on all of this across the globe. So that's how it is. And then as a pilot, we said now that open APIs, ETOM, SID and all are certified, now let's conform to the components. So we just took one of our platform called Geo Integrated Inventory Management, GIM, and we found that it is corresponding to 2 components of TM Forum, TMFC 008 and 012, which is service inventory and resource inventory. And then we said let's build it, deploy, and then we did it on Azure. We also did it on GCP, and then this is, and also we are doing on-prem. So we decided that we'll do it for one of our production deployments, and then that's how it is being done, and put the load on it. So that will be kind of a first major deployment, and then multiple teams who have already certified, they are going for componentizing their various functionality. So that's how we are working on it. And I think now I'll hand over to Naresh, who will be talking about more in the details of how it was done and how it is configured, and what real benefit you can see. So you can have a look yourself how it is beneficial, what kind of agility it provides.
Cool. Thanks Sudhir for setting the context. I'm going to quickly jump in, and let's talk about how we actually set up the canvas itself, right? The runtime environment that Sudhir talked about. So that itself is completely automated through, it's got a Git repository, it has a release pipeline. So at any point in time, I can destroy the entire canvas and bring it up. It's completely automated. Effectively, Terraform brings up the infrastructure, and using help to deploy all the operators that Sudhir talked about. On the right, you saw a whole list of operators. So all of those are also completely automated using help. Then when we double click and look at each of the APIs itself, right? So Sudhir talked about a whole bunch of open APIs that we have. Each API will have its own Git repository, will have a build pipeline, it will successfully generate a set of artifacts, okay? So you can have multiple APIs because any given component, any business component consists of a whole bunch of APIs, right? So think of them as a composition of APIs in a business manner, right? So effectively any one of them can change because requirement could cut across multiple APIs or just one API. When any one of them changes, they will trigger the release pipeline. Similarly, there is the concept of ODA itself, and ODA has a specification which has its own Helm chart and so forth. So that has its own build pipeline. So the way the definition of the component itself can also evolve. So that also is triggered through a build pipeline. Each of these would then essentially build the entire ODA. I'll show that in a minute. And then those will generate a set of artifacts which will then get deployed into an ephemeral environment, and that's where we will test everything, make sure that those ephemeral and in the ephemeral environments the components are working as expected, and on approval it will go on to the higher environment, eventually going to production. One of the challenges that I think Sudhir was talking about is this interdependency that we had, and we were trying to decouple these to allow independent development and deployment and automating the entire pipelines itself, right? So this is kind of like a very zoomed out view of how all of these pieces kind of come together and actually fit into our what we call as the path to production, the pipelines, right? So if we were to take and double click into any one of this thing, it's baked in with observability, right? So you would have like TMF, API 1, 2, 3, for example. Each of the APIs running in their respective pods. Each of them have a metric exporter, have a proxy, and then a data collector at the overall worker node. And if we now kind of look at the architecture itself, there are two parts in the Canvas cluster that we have. So you could have n number of components that are deployed, which is basically the set of services. Then there's a set of observability related capability that comes out of the box. So obviously you have Grafana for metrics monitoring, Prometheus for alerts and stuff like that, and we're using Grafana Loki for distributed logging. Istio, I think Sudhir mentioned about Istio. Istio is again a very important part for us. Then we use something called Sloth, which is for SLOs, so you can define your SLOs at individual service level, and that basically gets, that then defines rules, and alerts will be raised accordingly if any of the SLOs are getting compromised. We use Kiali for visualizing the network. And then we're using a whole bunch of tools. Again, we'll get into this bunch of operators. All of these then obviously raise alerts on Teams or whatever tool you're using internally. And then of course there's modern incident management for L1 and L2 escalations, right? So that's kind of a quick snapshot. The philosophy we've been using is everything as code. So essentially the whole GitOps kind of a thought process. Again, if we just look at what I just described, this whole thing, everything is in the Git repo. So the service, obviously, all of the code is sitting in Git. All the metrics exporters are also sitting in Git. Sidecar, the sidecar envoy, sidecar Istio, all of that is again coded. Log exporters are also as code. All of these again is essentially code. Custom rules, SLOs, pretty much everything I'll show you in a minute. All of these are, sorry about that. All of these are fully, as code, right, sitting in the repository. So it's not like someone has to go and, configure, change this thing in an environment of a scale like Geo. It's just impossible to manage that. So the whole idea here was to basically, automate everything and everything as code kind of a philosophy. So then we also partnered with Sudhir and we built this no poly, we call it no poly, which is basically a no ops observability stack. So the idea is that we want to reduce the amount of ops when it comes to this. We want to basically use this whole no ops philosophy. and observability has to be baked into it. We've kind of open sourced this stuff. So what it gives you is golden signals, dashboarding consistent across every service out of the box. Not a single line of code has to be written for that. That's completely out of the box. All the SLOs are also out of the box. Nothing needs to be defined. Your service graph using Kali comes out of the box. Deep tracing, so I'll show you a demo of deep tracing in a minute. Your whole monitoring, all of that stuff, centralized logging, all of these things. One of the interesting things here is often how do you know the health of your entire cluster, right? So you can know the health of individual components and stuff like that, but if I'm about to run a suite of tests or if I'm about to do a demo to an important stakeholder, I want to make sure everything's healthy, right, before I can do that. Sure, I can look at individual this thing, but I want an aggregate, so that's kind of what we try to solve here as well. So a whole bunch of things again that we try to address, but let's go into jump into a demo and see some of these things in action so that we can have a little better appreciation for what's going on here. So let me start with what would a developer need to do, right, to basically leverage this entire stack, right? So there's only 2 files the developer needs to know about, and pretty much everything else is taken care, right? So the first file is, you'll see this, this is a set of APIs, right, I have here. I have 3 APIs. In that I have a no poly config, and in that there are 2 files. If I look at the default .yaml file, I'm basically saying, okay, I have a container, it will be running on this port, and what is the name of this API that I'm exposing, right? And then in production, basically I can have environment-wise file, and what are basically the other containers that I'm dependent on, like if I'm using a database, how many replica sets and stuff like that. Some of these are, again, there's an extensive set of things that you can define and fine-tune. But if you don't define any of that stuff, we assume defaults and we kind of set it up for you, right? So that's pretty much what a developer would need to do, and then they do their standard development, right? So this is all they would need to do. Let's quickly jump to one of the pipelines and look at that. So I'm just looking at, let's expand this out. So you see here there's a bunch of pipelines here. So I'm just going to order API, one of the pipeline. Let's look at the build that just ran. So what you will see here is a whole bunch of, the tests have run for this, quality checks have happened. The image, the Docker image was generated, but before that, before it was pushed, image scans were done, and the Helm charts for this particular deployment was all generated. You didn't actually have to write any of this stuff as a developer. They all get generated out of the box. How can we do so much of generation? Because like Sudhir said, we've standardized, right? Once you standardize on the architecture itself, then generating these things become very trivial, right? You don't have to keep dealing with different variations. The only base thing you need here is a Docker file. Everything else can be just slapped on top of it. So that's, a whole bunch of tests have run in this, and this is generated. The code scans have run. You'd be able to see all of that stuff. But let's quickly look at the release pipeline, because I think that's kind of more interesting, right? So I was talking about individual APIs, each of them having a pipeline. So you'd see those here, order API, bunch of other APIs. And then this is my deployment workflow, my release pipeline. So if I actually go into my release pipeline, what you will see is when I ran my individual pipelines, they pushed the artifacts into the registry, Docker registry, and additional artifacts into an S3 bucket. Here I'm basically pulling from the S3 bucket, then I'm deploying into, EAT is the ephemeral automated testing environment. So it deploys and runs a workflow test. This is something new that we've done, which is essentially using Arazzo, which is again an open API specification standard. We can run an entire workflow on, like there are multiple APIs within a component. We want to make sure that that component is working as expected in an ephemeral environment. So that's what we do here. If I just click into this quickly, you would see that we have, essentially here, we're pulling the resources, we are running a whole bunch of things. We are executing the Arazzo workflow tests. and then we are publishing those results, So if I went back to the summary, let me just quickly download this. Okay, there we go. So just going to open that up real quick. And so this is again a very simple example, but what is done is essentially it's run a workflow across, it's getting a UUID, it's retrieving the product details and then placing a product order, right? Like it's a small workflow that you actually ran through. You can actually visualize this and look at what the workflow itself looks like. So it's a place order, then you're getting into the get UUID, retrieving the product. If it's on failure, you're ending the workflow. So you can quickly visualize what each of these looks, what the conditions it's checking and so forth, right? So all of this is now completely automated, running out of the box for you. So that was a little bit about the workflow itself. So once the deployment is done into the ephemeral environment and it's successful, then after that we would deploy into a staging environment, right? So let's quickly look at the staging environment and see what's happened. Can we just quickly generate some traffic on this? Okay. So that's basically the three components that we just looked at. We have an order BFF, an order API, and then a UUID API. And you'd see that if let's visualize the animation, the traffic animation on this, and also let's visualize the security. So you'd see these locks, which means these are all mutual TLS that's automatically set up. You'd start seeing that animation of the traffic flowing through. So all of this is again completely out of the box. The developer or the ops person didn't have to write a line of code or any of that stuff, and this is standardized across all your components, right? So it doesn't matter which component, all of this is standardized. Let's quickly look at one of these, right? So when I look at one of these, I can go in and look at essentially, let's see if I can look at the tracing. So we talked about deep tracing earlier, right? So I can click at this, and this gives you out of the box deep tracing for you. Again, you don't have to, we're using telemetry, so we don't have to write any line of code. It's all at the Docker level. You just need to inject one line and you get effectively the entire, let's see, refresh. There we go. So what you'll see here is that essentially a post request came to /products. You can obviously click into this and see what was the resource attributes and so forth and things like that. But essentially the request response pairs, all of that you would be able to visualize from here. Internally then it made another call to post UUID. It then basically did a select in the database, what query it executed, all the way to the full trace, right, is completely available. So if anything goes wrong, it becomes very easy to visualize where things went wrong and stuff like that. And this is again available as a pretty standard service out of the box. Can we generate some fault? Can we inject a fault? What I'm going to show you is that this is the happy path scenario, right? Everything is working great, but what happens if there is a fault in one of your systems, it's not responding correctly or things like that. Here here we'll be using Istio and we'll be basically using a proxy feature that it has to inject fault into it. Let's quickly refresh this. It might take a couple of minutes for it to just show up here, but you should see, these things. There we go. You see this thing has started turning red, which means this has a fault here. If I click on this, you'd start seeing, let's look at the, actually, let's go here. So you see this is turned red. And if I click and look at the span, I would be able to see where the fault is, what's happened. So immediately I should be able to get to know basically what the problem is. In this case, obviously we are injecting the fault, so we obviously know what's going on. But this is pretty good visualization for you. Also, the other thing is we talked about standard dashboards that are available. So here's the set of dashboards that are available out of the box. So if I look at the SLO itself, you'd probably see that now I'm starting to burn my SLO and even the alerts have started firing, right? So this, I would start getting notifications on, Teams that one of your SLO is being breached, right? And this is again using slots where we've set up these SLO rules and stuff like that. As a developer, we didn't specify anything, right? So we've assumed that for this particular component, you need a 99.9% availability. But in case you wanted a slightly different one, you could, change in that config file that I showed you. So there's again standard dashboards that we have available out of the box for you. I'm just going to quickly look at another dashboard. So let's maybe look at the BFF one. So you'd see that error rate has started spiking up over here. This is an individual service dashboard, and you would see, essentially the requests response counts, the size, CPU utilization, memory utilization, all of that is kind of standard built out for you. Okay, that was probably a quick demo. There's additional functionality. Of course, we don't have 2 hours to kind of go through all of them, but you'd be able to see that there's a lot more that you could do on the security side of things. I'm just going to quickly zip through this. Network policies can be set because we know which component needs to talk to which component, so that can be automated. You don't need to individually go and configure your network policies. You can basically, I talked about ephemeral environment where we use Specmatics operator to automatically look at what are the dependencies and build stubs out of that for you dynamically. We have integration with Sentry for error tracking, centralized service rate limiting, RBAC. We're using an interesting tool called Falco for looking at security breaches in the in your environment, and any anomalies can be automatically detected and pointed. Mutual TLS, all of these things. I know I've taken a little bit more time, Sudhir, but back to you for quickly wrapping up.
So thank you, Naresh. So that was really, and I must tell you, it was really exciting to work with with Naresh and other teams to really, bring all those concepts, visions, and all to really fruition in the production, and that's how the language which developers understand, right from architecting it right. So the problem in front of us was heterogeneous, huge dependency and all. But then the key takeaways with us was innovation, continuous innovation, and standardization, which was very essential. So that was actually the winner, because the moment you standardize and it is adopted across, whether it is terminologies, processes, information, APIs, components, the deployment, the runtime, the observability, dashboards, everything is standardized, and that is the key. And then you will need to innovate to bring more and more productivity and efficiency, and that's another topic we are working on. And then the collaboration and wide scale adoption, because we do this, but what do we, how do we tackle it, all those standardizations. So it's like if just I think about certain standardization the way it should work, that is not going to work. It has to be adopted, accepted across. So what we did was we formed a, we joined hand with TM Forum, as I said earlier. We formed Innovation Hub, and that was inaugurated by Akash Ambani, our chairman, and also the founder members were Jio, Orange, Telenor, Vodafone, and Google, Accenture, and then later on we have a flurry of more Microsoft, AWS. Everybody has joined Innovation Hub, and now we are collaborating more. Whether we are talking about the service providers, software vendors, hyperscalers, system integrators, IBM also. So that way, all of us are sitting together, working on multiple problems. We are running multiple projects there, collaborating, standardizing various things, and agreeing, and then adopting. So that when it is adoption is done at a wide scale, and that's where the real power of innovation comes up. And I'll be just quickly talking about what's coming in future. So AI is the further piece which we are working on this ODA canvas with operators and all. So we had APIs, reusable components, and now we are talking about intent-driven reusable components. So I was talking with one of my colleagues yesterday, Ravi, and then we were talking about that, if suppose some release has to go, which is involving, multiple components, then if I take just one component, how does it start functioning for a particular feature which is expected by the other component. So today this is deployed first, and the other component will be deployed later on maybe. And then that is the kind of intent which this first component which is deployed in the production has to understand. So every of these components have to really become intent driven and AI native. And that's where we are working on actually two folds. One is bringing the key functionality of virtual assistants, which is like AI VA, AI virtual assistant, putting that as a component itself, putting that as and some of those parts as operator itself, which are available for everybody to consume, every component to consume. And second piece is putting within component the capability of consuming that. So now if we see the operators, earlier we had API gateway observability, which Naresh showed you a demo, and MLOps and vector DB and all, AI model catalog use case registry and guardrails, etc. All of them are being thought as a canvas operator which are available for reuse. And that's how we want to take our telcos too, and then this is telcos, and today we are talking about telcos becoming more techcos, so that way IT and telcos boundaries being fuzzy. And so all of them, future telco business will be really AI and then network. So that is the third thing we are working on. AI is not on the IT side, but AI is there on the network side also, and then the boundary is now blurring again from the network side and IT side. And then the whole monetization process, the operations process, and all of them are becoming AI native, leaner, greener, more agile, and more profitable. That's how it is working. These are the various horizons of our work, and if you see that we are now talking about AI native canvas, which is on horizon 3. These two are by and large delivered, and then we are also working later on carbon management, because today in large organization, I've seen in multiple telcos at least, that people take hardware and they never return. So the hardware and the carbon footprint keeps on increasing and increasing, and that's a big problem. And so a lot of work is being thought about in carbon management side also. So that is by and large what we had to talk about, and taking our vision forward, bringing more agility, productivity, and efficiency in the whole ecosystem. And thank you for that.
Anyone has a
Questions?
Let's say there is a new telco that wants to adopt ODA. What does it mean for them? Like, there's a great tech stack. You have the whole process, observability, all that laid out. So if it's somebody new who wants to adopt this, what does it mean in terms of trainings, maybe like staffing for cloud engineering, DevOps, and that sort of thing. So, yeah, just how would anybody start using this, or within your TM forum, how would you onboard a telco to start using it?
Yeah. Okay. So I think good question. When you say new telco or new organization, it means two things. One is new might be a green field, or new might be a brown field, very old actually, but want to be new on the ODA side and all. So I think both are good. For a new organization, it's pretty simple because all of these processes are, if it is a greenfield organization, all of these processes are set up. But the brownfield organization who have been working with legacy for years, and you know, even if I was talking about in Geo, we adopted it from day one, but then you know the technology also has evolved, and we have a lot of legacy stuff also now running. So the problem is that how do we transform, and that's a bigger problem actually. And then that's where said the journey starts with actually you know the certification at a wide scale. So people have to understand that they have to certify. In the moment you say train, people get trained, it's fine, they half a time they nap and get good food and just roam around and come back. But the goal was not training. The goal was certifying your open APIs, your processes, your information models and all. And that had a very clear matrix, you know, visible on TM Forum website. It's not like organization is having a website. So we are certifying, go to TM Forum website, see the number of certifications going on, right? So that way, that provides a lot of awareness to all the developers, all the team leads and departments, the groups and all. And once that is done, then you know you will naturally see components carving out of that, because you have standardization, and as I showed the definition of a component, it consists of all of this. And then as a parallelly, you just set up you know canvas and start deploying. Converting a legacy software to a componentized deployable on canvas, there have been paths for that, how it has to be done. It could be a COTS product, it could be in-house very legacy product, it's all fine. But then you know you put some kind of a proxy component and then you start putting there and then you work on releases. The basic you know problem is the decoupling of all of them to have independent releases and deployment, and that's where I think it will work.
And you brought up the point of your tech stack itself evolving, right? Like newer versions of tools and services being released. How do you take care of that? Because you have a certain tech stack, you have all your scaffolding around that, and now that has evolved. One is you update your framework itself, but also you have to sort of percolate that to all the companies that are using that.
So, you know, definitely there are some tools, and in fact, that's one of the problem I was discussing with my colleague, that, you know, our operations teams are, for years, they have set up a good tooling, but, you know, everything has to evolve, and we have to see the kind of dynamics it produces, and that's where it is very, very important. And, you know, tooling, one thing is for sure, some things have to be adopted. For example, the containerized environment, when we talk about carbon management, reducing the footprint, on need, on demand, expansion and all. So containerization is a reality, Kubernetes is a reality, and the associated tooling, whether I talk about observability and all, comes naturally with it. So some things, you know, it's make before break. So you need to adopt certain tooling which are coming out of the box, you don't have to do, and all of them is like based on open sources, you don't have to pay a penny. And that's how, you know, big startups, the startups become big. And, you know, we have to have, whether it's a large organization, small organization, every individual has to have that startup mentality, that we have to have very frugal in our approach, and, you know, adopting more and more standard frameworks and all. So we have to discard some of the old processes, but, you know, obviously make before break.
Just to add, I think I just brought up this page that they do have fairly, you know, if you go to TM Forum, you would see that the APIs are fairly well documented. There is a reference implementation available. There is a CTK, which is a conformance toolkit or a certification toolkit available. So, you know, Sudhir, we worked with TM Forum to actually build this, you know, the entire factory for them. And what you will see is that this becomes a good starting point for any organization that wants to start. They can start at a, at an API certification level, like Sudhir said, and kind of gradually kind of grow up from there, right? And you'd see like a lot of resources are available. And we've been at TM Forum, we've also been talking about how do we take this outside telco, right? A lot of this stuff that is done is not specific to telco, right? A lot of this stuff can actually be beneficial to other companies as well. So there is a parallel thought process on how do we take this and make it accessible. In fact, if we look at Jio itself, right, we're not just a telco, right? We have retail, we have a lot of other things. So how can we benefit this across internally in Jio as well? Right, so the thought process is while this thinking is being done on the telco side of things to start with, but a lot of these are cross-cutting concerns, not specific to a particular domain or a vertical. So yeah, I think that's kind of where we are thinking about this. Earlier I just brought up that list, so you'd see Airtel, you'll see a lot of other companies, telcos around the world have adopted, and that's I think where TM Forum really shines. So if you see, they just announced 1 million downloads of their APIs, right? That's a significant milestone, and it's being adopted by all because the whole purpose of TM Forum was to bring that standardization, so interop can be easy between telcos, right? And one does not just stick to one particular operator, is traveling, etc. And so everything has to be interoperable. So in India also, like a whole bunch of telcos have already adopted these things.
And there are a lot of things we have not invented. So it's like if you talk about ODA Canvas, it is a work of Vodafone UK. So Lester Thomas is the chief architect of Vodafone. He developed this concept and then he said that let us standardize. That's how collaboration worked. And then with TM Forum members adopting it more and more, and Jio also started adopting it. So that's how it has gone. So it's a huge collaboration. As I said, Vodafone, Orange, Telenor, Bell Canada, Verizon, and all. So various companies are working with TM Forum and standardizing these. The only thing is that with kind of setting up the initiation we have taken in Innovation Hub is where there's a very focused effort which is going on. So there is a sprint defined by all of these partners together, and everyone donates a few developers and architects, and we spend our own personal time there, and then we just said that in the whole global industry, and we're not talking about only India, so it's globally, everybody adopts it, agree to it, creates a reference implementation, and simply imbibes in their own architectures.
Thank you, Sudhir and Naresh, for that wonderful session.
Thank you.
Thank you. Thank you.